Hello, I'm Nour Ammar. I'm studying data science and artificial intelligence master program in Istanbul Aydın University in Turkey. Today I will introduce deep learning natural language processing project entitled Movie Reviews Text Sentiment Analysis based on LSTM. We will open Jupyter Notebook based, based on Anaconda platform. Here we start with training model. First, we import the libraries. We use Python 3.9 version. Here some record libraries. Here is the TensorFlow platform, NLTK library for processing language, NumB for processing numbers, Keras for processing the deep neural networks. First, we import the data, read the data set from CSV format. Its dimension is 50,000 with 2 dimension, 50,000 reviews with positive or negative values. Here is some examples of reviews, the data set shape. Here, one example. We must pre-processing the data by cleaning it from unwanted marks. Here we have conversion between it before cleaning and after cleaning. In this cell, we refer to positive review 1 and negative 0. And now we split the data. In this project, we depend 70% ratio for training data, 10% validation, and 20% ratio for testing. Tokenizing data means taking the meaning word and leaving the other not important words. Then we convert them to sequences with length 256 only. We depend on dictionary GLOW, which is a dictionary of word embeddings with 200 dimensions. It's a dictionary of sequences to refer words, meaning words to it. Now building the model. Here we have two basic LSTM layers. First with the 128 neurons features. The other is with 332. So we depend on this model for activation function. We use sigmoid. For optimization function Adam. For loss function mean squared error. Here is the summary of layers of the model and number of parameters. As we see, the input is 256 multiplied by 200, and the output is 1, either negative or positive. Here is the plot of layers with its dimensions, input and output. And here is the training batch size of 140 and 16 watches. Here we plot confusion matrix. As we see, 2 values is more than negative values. If square is high, test score and accuracy. Accuracy is 87%, validation also. Here we have plots of accuracy and loss in both train and test data. As we see, from low to high in accuracy and lows from high to low, which are good training. Each approach is coming higher. After we finished our training, we save the model to use it later in H5 format by Keras library. Now we go to testing model. Here we copy the important cells to keep the data and pre-processing. Now we start testing. We test the test data that's split before. As we see, here we have 10 cases. When it is near to 1, it is positive. When it is near to 0, it is negative. Here we show the sequences of each sentence. Each number is a word, actually. Here is the probability of prediction, which is near to 1. That means it's a positive review. I can test it by myself. I prompt the user to write anything he wants. For example, I like the movie. It is fantastic. I will invite my friends to watch it. The acting was perfect. Now I will enter. Here is the result predicted, near to 1 positive review. We have other examples. As we see, they are true predictions. And that's done. For showing visualization, I do some code to import tensor board localhost. And here we have some diagrams. As we see, histograms of the layers. Here is the first layer of LSTM histograms, and the second histogram, LSTM second layer, embedding 0, the first layer for training data. Here we have the images of activation function denotation in LSTM layers. Here we have the second LSTM layers. White is 0 and black is 1. That's how words is understood by the model. And here we have the 3D diagram showing the embeddings of our data. That the 200 dimensions embeddings in the first layer. Each point is a sequence, and we reduce them to this number of dimensions, 32 multiplied by 128, as we will see in the last layer. Here we have the graph of TensorFlow computation. That's it. As we see, sequential model, mean squared error function and Adam optimization function, and how the tensors are flowing. That's it. The code will be published on GitHub. Thank you for watching. Bye.